Hello students, this is our lecture number 63 and the last lecture. Hence, we are completing our subject in this lecture. 90% of the syllabus of mechanics of solids will be completed over here. So let us discuss today's lecture, which is our last lecture actually. Okay, so just concentrate on some numericals and then after we will discuss some theories also. We will conclude 90% syllabus of the subject mechanics of solids. So this is our last lecture. No other lectures will be posted after this. So concentrate on the last lecture 6.3, numerical number 6.3. Steel bar 2 meter long, 20 mm wide and 15 mm thick. So what is given in the data? L equal to 2 meter, 2 into 10 raised to 3 mm, width B 20 mm, thickness T 15 mm. Everything should be taken in mm only. Subjected to tensile load of 30 kilonewton. So P equal to 30 into 10 raised to 3 Newton. What we have to find? Increase in volume means delta V. Poisson's ratio is 0.25 means 1 upon m is 0.25. Or you can say m is equal to 4. 1 upon 0.25 that is 4. Young's modulus is 200 gigapascal means 200 into 10 raised to 3 Newton per mm square. Now let delta V equal to increase in volume of the bar. Delta V is equal to increase in volume of the bar. So now, what is original volume of the bar? It is LBT. So LBT, you will get the answer of 610 raised to 3 mm cube is the unit of the volume. Now what is the formula? Delta V by V is equal to P upon BTE means P upon area stress upon E, 1 minus 2 by M. This is the formula as discussed in the previous lecture. So replacing all the values are available, you will get the answer of 0.00025. So now cross multiplying this volume, we will get delta V 0.00025 into V. We have calculated earlier 600 into 10 raised to 3. So by multiplication we will get the answer of 150 mm cube. So this is very simple numerical to find the increase in volume. Let us discuss one another numerical 6.4. Copper bar 250 mm long and 50 by 50 mm in cross section. So length is 250 mm, width is 50 mm and thickness is also 50 mm. So area will be 50 into 50, B into T, cross sectional area. Is subjected to axial pull in the direction of its length. So in the direction of the length, the axial pull P will be applicable. If the increase in volume of the bar means delta V is already given here, 37.5 mm cube. Find the magnitude of the pull means we have to find force P. Take m equal to 4. So 1 upon m is equal to 1 upon 4 is equal to 0.25. Poisson's ratio. So E equal to 100 gigapascal means 100 into 10 raised to 3 Newton per mm square. We have to find P. What is the formula for volume LBT? So LBT, all the values are available. We will get the answer 625 into 10 raised to 3 mm cube. What is our formula? Delta V by V is equal to P by BTE 1 minus 2 by m. Without P, all other values are available. Here it is minus. Here it is minus. Okay, so answer will be delta V by V is equal to P upon something like that. So by replacing and making the subject as P, you will get the answer 30 into 10 raised to 3 Newton. It can be written as 30 kilonewton. So very simple numerical, nothing difficult in this. All the values are given in the data. You just have to replace in the appropriate formula and you will have to find missing values. Nothing else. Let us discuss next topic, which is volumetric strain of a rectangular body subjected to 3 mutual perpendicular forces. In the previous case, the rectangular body is subjected to one and only one tensile force, which is along the length direction. But in this case, you can see X, Y and Z. Along all the 3 directions, tensile forces are acting. So sigma X, sigma Y and sigma Z are corresponding stresses in X, Y and Z direction respectively. E equal to Young's modulus. Now as you can see, what is the formula of strain? So strain will be stress upon modulus of elasticity, which is according to Hooke's law. So similarly for all the 3 directions X, Y and Z, if you are discussing about X direction, then epsilon X equal to sigma X upon E. Similarly for Y direction, epsilon Y equal to sigma Y upon E, and for Z direction, epsilon Z equal to sigma Z upon E. This is as per Hooke's law. What we have to calculate? We have to calculate delta V by V means volumetric strain. This is the empirical relation you mug up, you just mug up it directly. There is no derivation, no perfect derivation for this. So for that, you just have to take epsilon x, epsilon y and epsilon z. What is epsilon x? If you are taking x direction, then sigma x upon E alone, while another two values will be negative and it is divided or multiplied by Poisson's ratio also. So sigma y upon me, sigma z upon me. Sigma x upon E, in this first term there is no Poisson's ratio because it is x direction. So you have to remember like this, manually or empirically. Then after 1 upon E will be common out and the remaining terms in the bracket. So which will give the answer of epsilon x. Similarly for epsilon y, 1 upon E will be common out, sigma y will be there because it is y direction and rest two terms are for x and z with the help of Poisson's ratio. Similarly for epsilon z. And what is the volumetric strain? So delta V by V is the volumetric strain, which is the addition of all the linear strains in three directions, epsilon x, epsilon y and epsilon z. So this is very empirical relation. There is no base for this. There is no particular derivation for this. So you just remember this formula. Let us go ahead. One example based on this. 6.6. A rectangular bar 500 mm long and 100 mm by 50 mm in cross section. You can see 500 is the length, width is 100 and thickness T is written over here 50. And the different forces 200, 100, 300 is given. 300 is compressive while 200 and 100 is tensile. 100 kN force is along the length, 200 kN along the width and 300 kN is along the thickness. What we have to find, what is the change in volume of the bar, means delta V. Take modulus of elasticity, E equal to 200 gigapascal, means 200 into 10 raised to 3 Newton per mm square. 0.25 is the Poisson's ratio of 1 upon m, or you can say m equal to 4. Now, in the x direction means Px is equal to 100 kilonewton, 100 10 raised to 3 Newton, which is tensile. In the y direction Py 200 means 200 10 raised to 3 Newton, which is tension. And in the z direction Pz equal to 300 kilonewton equal to 300 10 raised to 3 compression in Newton. All the values, length, width and thickness is given to you. What we have to find? Change in volume of the bar, delta V. Let us see what happens. Actually, exactly like the theory, you just first find volume, original volume, LBT. LBT is given to you. So answer will be this mm cube. 2.5 into 10 raised to 6 mm cube original volume. Then after you just calculate three stresses. Sigma, x, y, z. Sigma means P by A, P by A, P by A. If you are taking x direction, then it is Px by Ax. Now this is the force along the x direction. So you have to take this cross section area, which is perpendicular to the force, which is 100 into 50. So you can see here 100 into 50. And P is 100 kilonewton, means 100 into 10 raised to 3. So answer will be 20 Newton per mm square tensile, because the force is tensile. Similarly for the other two stresses. Sigma y equal to Py by Ay means along the y direction force is 210 raised to 3 tensile. Then you have to take this area, front area, which is 500 into 50. So answer is 8 Newton per mm cube. Here it is square actually, printing mistake. The unit of the stress is Newton per mm square in tension because the force is tensile. And similarly for the third direction Pz by Az, the force is 300 on the top view. So you have to take the area of top view, which is 500 cross 100. So your answer will be 6 per Newton per mm square in compression, because the force is compressive. So stresses are available now. Then after find strains, epsilon x, epsilon y and epsilon z. So what is the formula for it? Here is the formula. You can see E will be common out as per the theory. There is sigma x will be 20, sigma y will be 8 and sigma z will be 6. Here, remember here in the theory the sign will be negative. But as the third force is compressive, so sign will becoming positive in all the cases. So this is positive. While taking epsilon z, the remaining two values negative, but the first value become minus because of the compressive stress. So remember this type of cases, you know epsilon x, epsilon y, epsilon z. For this, you have to just remember this formulas. By simplification, you will get the values 19.5 by E as epsilon x, 4.5 by E as epsilon y, minus 13 by E as epsilon z. Now, as per the formula, delta V by V is equal to epsilon x plus y plus z. So delta V we have to find. original volume we have calculated earlier, and epsilon x, y, z, just replacing all these three values, which is in total 11 by E. So by solving in the calculator, you will get delta V is equal to 137.5 mm cube. So very simple numerical, just calculation is very tedious. You have to remember the formula first, then after by replacing the values, you will get the answer very quickly. So nothing else in this. This is the completion of the numerical. Let us see one more numerical for your practice. 6.7. What is given in the data? Steel cube of block 50 mm side. This is 50 mm. 6, 4 and 8. Now 8 is tensile. So while you are taking the force 8 kN, you have to take this area, means 50 cross 50. In this case, actually it is the cube. So all the areas are equal. So it is very easy for you, 50 cross 50 whenever the area is required. Now delta V, what we have to find? Just 6 kN, 8 kN, 4 kN are the forces along the x, y, z direction respectively. Determine the change in volume. So again we have to find delta V when epsilon is given as 200 gigapascal and Poisson's ratio is m as 10 by 3. So 1 upon m will be 3 by 10.3. Okay, ready? Let's start the numerical. What is the original volume? 50 cross 50 cross 50, which is 125 10 raised to 3 mm cube. Now, as per the previous method, just find stresses, then after strains. So what are the stresses? Epsilon x, y, z, which is equal to px, py and pz upon area. Area remains constant as the cube is having same faces, 50 cross 50 along all the directions. Px is 6 into 10 raised to 3, py is 8 into 10 raised to 3 and pz is 4 into 10 raised to 3. So by calculating, we will get this type of values. The sigma y will be compressive as 8 kN is going inside, means compressive force. Now finding epsilon x, y, z, according to our formula, this is the formula. But epsilon y is, sigma y is negative because compressive. So whenever there is sigma y, the formula becoming minus minus plus. Here sigma y is the first term, so it will become minus. And here sigma y is the last term, so it is becoming minus minus positive. By replacing all the values which we have calculated, so final answer will be like this: 2.88 upon E, minus 4.4 upon E and 1.84 upon E. Now as per the formula of volumetric strain, delta V by V is equal to epsilon x plus y plus z. By replacing all the values, we can get the answer of delta V. Now the total is 0.32. By making the subject as delta V and replacing all the values, we will get delta V equal to 0.2 mm cube. So both the examples are very similar time. You just practice out these formulas and just replace the values. Higher speed in the calculator is required to solve the numericals. So you just practice on the calculator also. Let us go ahead. Now only two topics are remaining, that is very small relations, mathematical relations. If you have asked in the GTU exam, or with the help of these numericals, with the help of these relations in the some numericals, you can find the missing values also. We are not going to solve this kind of numerical because they are very easy, but you just remember the formula if you can be asked in the numerical forms. Let us see the definition of bulk modulus. When a body is subjected to three mutually perpendicular stresses, means x, y and z direction, of equal intensity, means all the stresses are equal, the ratio of direct stress means sigma, to the corresponding volumetric strain. So volumetric strain means delta V by V. So this type of ratio is known as bulk modulus, which is denoted by capital K. Mathematically, the bulk modulus is sigma upon delta V by V, means direct stress upon volumetric strain. Now there are two relations. First one is relation between the bulk modulus and Young's modulus. Bulk modulus means K, while the Young's modulus means E. So the relation is given by K is equal to ME upon 3 times M minus 2, where 1 upon M equal to Poisson's ratio. So M is the reciprocal of Poisson's ratio. This relation is having derivation also, means this formula is not directly available. Actually this formula is derived in the textbooks, but this type of derivation is not of much importance for us, or in the GTU exams this type of derivations are rarely asked. So we are not going towards the derivation of the formula. Just remember this formula for the numerical purpose if the numericals can be asked. K equal to ME upon 3 times M minus 2. Similarly, the last topic is shear modulus, or we can say modulus of rigidity, which is denoted by C. So now we can find experimentally that tau is always proportional to phi. What is phi? Actually, in the chapter of torsion, you can see the shaft is twisted, then the angle subtended at the back side is phi, which is known as shear strain, which is equal to displacement divided by original length. So that is known as shear strain, A dash upon L, if you remember that. So tau is proportional to phi. It is the experimental relation, which you have to directly accept. Now, as per the mathematical rules, when the proportionality is there, and if you want to replace it with the equality, then the constant must be there, which is known as C, which is known as modulus of elasticity, modulus of rigidity. So tau by phi is equal to C. C is also written as G or N, capital G, but C is popular. So tau is equal to shear stress, phi is equal to shear strain, and C is equal to constant known as shear modulus or modulus of rigidity, which is also denoted by G or N. And similar type of relation is also available for this. The relation between modulus of elasticity and modulus of rigidity. Modulus of elasticity means E, while the modulus of rigidity means C. So C is equal to ME upon 2 times M plus 1. So this is the modulus of relation between modulus of rigidity and modulus of elasticity. So that's it for the chapter. Our chapter is very easy. Last 3 to 4 chapters are very small, having 2-3% weightage in the JTU exam. So as of now, we are completing 90% syllabus of mechanics of solids, and this is the final YouTube lecture. There is no YouTube videos will be posted after this. If you have any doubts, then please ask me personally for any type of doubt in any chapter. So prepare well for the exams. JTU exam will be conducted this time. This time no merit progression is given to you. So just revise all the videos. There are 63 videos, which is not an easy task. So you just complete the revision of 63 videos in Diwali vacation. So happy Diwali, happy vacation, but must remember this 63 lectures. Thank you very much, students.